you get an overall exothermic reaction. This down here should say NaCa solid down here at the bottom. We're forming it. Heat of formation right there of NaCa solid. Okay. Okay, covalent bonding. So this is different than ionic bonding. Covalent bonding has a lot of stuff going on. In covalent bonds, atoms share electrons. And there are several electrostatic interactions in these bonds, attractions between, let's start with this one. Attractions between, whoops, help if I actually had my pen on. There we go. Let's start with this one, attractions between electrons and the nuclei. So you've got an attraction that exists between a positive and a negative, okay? And you've got another attraction that exists because you've got two nuclei, you've got two things that are attracted between this positive and this negative, okay? Repulsion between electrons. So here you've got this electron right here does not like this electron right here. They're going to push each other away, okay? You also have repulsion between the nuclei. These two positives do not like each other and are going to push each other away, okay? And so this here is trying to show you, remember the timestamp on the electrons supposedly that are bouncing around? This is showing you that the electrons are being shared. Look at, they're time stamping everywhere, all around, okay? And they're being pretty much equally distributed in this case because of these electrostatic interactions. Okay, polar covalent bonds. Here's the thing. This one looks a lot like what we just saw on the last page. It looks pretty evenly shared, okay? This one, however, doesn't look so evenly shared. This looks like there's a lot more electron stuff going on over here than there is over here, okay? Well, what's different about these two things? This one is two of the same atoms. This one is two different atoms. Electrons are not always shared equally, okay? If you take a look at electron affinity, just to start out, fluorine is a much more electron affinity, has a much more negative electron affinity than hydrogen does. So it wants those electrons a lot more. And then we start talking about electronegativity, which we brought up during our trends, but we actually can put a number to now. Electronegativity is the ability of atoms in a molecule to attract electrons to themselves. So what this is saying is that fluorine over here is very electronegative. And hydrogen, not so much. Okay? And then here we've got a little periodic table to show you that electronegativity increases this way, okay, and increases this way, sort of, because it's kind of all over like electron affinity was. The two are very related. So it's more of a trend in that direction, increasing electronegativity, okay? All right, then we've got something called polar covalent bonds. If we've got two things that are sharing, we have the possibility that they can be a polar covalent bond. They might have a dipole moment, which is produced when two equal but opposite charges are separated by a distance r, and it's calculated with that equation. This is an example of a dipole